Alright, so today we're going to be looking at domain and range when sometimes you'll see that we don't have any bounds. So we may not have a lower bound, we may not have an upper bound. So before we begin that, I want to take a look at the XY plane and talk a little bit about infinity. So if we take a look at this grid right here, something that you may have noticed when you see these is that you have 4 arrows, one on the right, one on the left, and then up and down. Now these arrows are telling the reader that the sequence of numbers does not end here. Even though it looks like it ends, we can still extend this. So this extension keeps going on and on and on. So we still have a 7, we have an 8, we have a 9, and then it's going to be impossible to write all of the numbers to the right here. So instead we use this convention. We put 3 dots and then we say that these numbers are going to go to positive infinity. The same can be said for the left hand side. So here we can extend this, and again as our numbers keep getting smaller and smaller as we keep moving to the right, you can see that here we can use this concept of negative infinity. And if we take a look at the directions above, pointing above and pointing below, we can say that here we're going to go up to positive infinity, and then here we're going to go down to negative infinity. And actually I meant as we're moving to the left. As we're moving to the left, we're going to reach negative infinity. Alright, so let's begin by getting the domain of a graph. So right here, as we look at this yellow graph, we see that we have an arrow on the right hand side. Now this arrow is extending to the right, so we can kind of imagine this graph never ending and keep extending to the right. So now as something happens with the x values, so as my graph keeps extending, you see that my x values keep getting larger and larger and larger. So here at 5, my graph was here, but then at 7, my graph is here. So you can see that these x values are going to keep going and moving to the right as this extension keeps progressing, and it's never going to end here because we have an arrow. So here we can say that our numbers are eventually gonna shoot towards positive infinity. So now let's get the lower bounds and let's get the upper bound of this graph here. So let's begin by again looking at the x-axis, since we're looking at the domain, and the domain is the set of all x values that are within the boundaries of this graph. So as we move from left to right, we notice that we encounter the lower bound here at -2. Now since we have an open circle, we can slice this with a dashed line. So -2 is the lower bound. Okay, perfect. So now we keep moving to the right, to the right, to the right. But notice that we're never going to find an upper bound here, right? Our numbers are going to keep going towards infinity as our graph keeps extending. So here we can maybe think about infinity as being the upper bound. So we can write this domain as such. We can say that the domain is -2 less than x. And again, the less than comes from the fact that this was open. And then we can write less than infinity. Now, every time you use infinity, all of your quantifiers have to be strict. You're never going to put an equal to here. X cannot equal something that's not a number. Okay, good. So now, if you're a beginner, maybe this is a great way to start understanding it or having an intuition on what the graph is telling you. But a better way to write this would just be -2 less than x. Okay, we don't really need to emphasize that it's not bounded from above. if psychologically this bothers you, you can also rewrite it so that the x is on the left hand side. So you can rewrite this as x greater than -2. So these three are correct. Alright, let's take a look at this one now. So here we notice that this time we have an arrow on the left hand side of this graph. So our extension of the graph is going to be in this direction right here. And again, I want you to, since we're talking about the domain, I want you to notice the x values, how they're changing. So here, as this graph keeps going above, or keeps extending from above, you see that my x values keep getting smaller and smaller and smaller. So here at -6, the graph is right here. Then at -7, it's somewhere around here. And since this keeps going on forever, again, these values keep getting smaller and smaller and smaller. So they're shooting towards -infinity. So now let's see if we can, and let me label this for x-axis. Let's see if we can find the bounds of this graph here. So now, again, we read from left to right. So from left, we're coming from a direction of -infinity. So we don't have a bound here. So we can kind of say that, I guess this time our lower bound is -infinity. So we keep moving to the right, to the right, to the right. And let's see if we can have, where we can find an upper bound. And we see that we have an upper bound right here at 3. And this is closed, so we can cut through it with a solid line here at 3. So now for any general x, it's going to get squeezed between this +3 and then this notion of infinity, -infinity to be precise. So let's write the domain. Domain is -infinity less than x, and then less than or equal to 3. So this time the less than or equal to comes from the fact that this is closed. And again, as I mentioned in the previous problem, we're never going to put a less than or equal to when we have infinite. So again, we don't have to specify the bounds when when we have infinite. So we can just write this domain as x less than or equal to 3. Alright, let's do one last one. So here we have a parabola. So now notice here that on the right hand side, this parabola keeps extending, keeps extending above, and then on the left hand side it's doing the same thing. So here, if I kind of move the graph a little bit, we can see that this one keeps going up, and then this one keeps going up. So on the right hand side, my values keep getting larger and larger. So we're shooting towards +infinity. And on the left hand side, the values keep getting smaller and smaller. We're shooting towards -infinity. So if we want to get the domain of this graph, well, it's actually pretty easy because we don't have a lower bound and we don't have an upper bound. So we say, whenever that happens, we say that the domain is the set of all real numbers, because any real number will satisfy the domain here, or will be part of the domain. And now if you want to impress someone, maybe you can say that x is an element of the set R. But this is enough for us.